Today, I'll show you an experiment on input characteristics of transistor in C configuration. So before conducting this experiment in Proteus, I will explain what are the different configurations available in a transistor. This is a junction transistor. In any junction transistor, there are three terminals available, emitter, base, and collector. So these three terminals, I am representing by emitter by E, base by B, and collector by C. And in any circuit, one of these terminal, either emitter or base or collector, it has to be common for input circuit as well as output connection. So this part is input connection and this part is called as output connection. So one of the terminal has to be common for input terminal and output terminal. So based on this, there are three configuration. If emitter is common, see here, the emitter is common to input and it is common to output. So such type of configuration is called as common emitter configuration. If you make base as common, see here, the base is common to the input circuit and to the output circuit. Such configuration is called as common base configuration. If collector is common, this is collector, base and emitter. Collector is common to input terminal and output terminal, and such configuration is called as common collector configuration. But today I am showing you common emitter configuration. So this common emitter configuration is one of the most widely used transistor configuration in electronics due to its desirable characteristics. In this C configuration, emitter terminal of the transistor, it is common to input. Input is base emitter and output is collector emitter circuit. Collector emitter circuit is output circuit. Base and emitter circuit is input circuit. Between these two circuit, emitter is common. So the emitter is the reference for both input and output signal. Here the input signal flow and here the output signal flow. The input signal is applied between base and emitter, and the output is measured between collector and emitter. So this circuit I am going to construct using the Proteus circuit. So in this circuit, I need to measure the base current, I need DC ammeter. To measure the voltage between base and emitter, I need voltmeter, DC voltmeter. To measure the voltage between collector and emitter, I need another voltmeter. To measure the collector current, I need DC ammeter and one power supply, variable power supply on the output circuit and one variable power supply in the input circuit. I can't have the variable power supply directly in a Proteus. So this variable power supply is I can construct using a DC voltage source and a pot. So how to make the variable power supply in Proteus, that video already I have done. You go through that, you will come to know how to construct the variable power supply using DC power source and a potentiometer. Okay, next. So after conducting the experiment, I will draw the characteristics, that is graph between voltage and a current, voltage on x-axis and current on y-axis. So the voltage is input side voltage is between a base and emitter, it is VBE, and the current flowing in the input circuit is base current, that is IB. IB is very, very small current, so you should keep it in microampere mode. So IB in microampere, VB in volts, and to plot the input characteristics, I should keep the voltage at the output, that is voltage between collector and emitter, constant. So then only I can draw the input characteristics. The input characteristics of common emitter configuration, it gives the relationship between the base current and the base emitter voltage while maintaining the collector emitter voltage constant. You can take many number of sets. First you keep VC equal to 0, get the values. Then in the next setup, keep VC equal to 10 volts, get the values keep Vc equal to 20 volts, get the values. So like this, we can get many number of curves in the input characteristics. Okay, so the base current, it is the function of base emitter voltage. So as the VB increases, if I increase VB, if I increase this voltage, the base current also increases. Okay, so if I, in the base current, it is the function of VB voltage. As VB increases here, as VB increases, IB also increases. So this is the first step. And at lower values of VBE, see, at lower values of VBE, the base emitter junction does not conduct significantly. Therefore, IB is almost zero. See, here it is almost on the x-axis. IB is negligible. This region up to here, it is referred as cutoff region. Cutoff region means transistor will be in off condition. Next, as VB increases further, beyond the threshold voltage, that is 0.7 volts for a silicon transistor. So at 0.7 volts, the IB starts increases. Up to 0.7, it is almost zero. After 0.7, the current starts increases, and it increases sharply. Because the base emitter junction becomes forward biased and IP increases sharply. And this region is called as active region. This active region is very useful in transistor amplification properties. So this is all about the introduction of common emitter configuration. Now I'll show you how to conduct an experiment in Proteus using common emitter configuration. So you should click on the Proteus software. So create a new project. Okay. Give the name of the project as input characteristics of transistor. Okay. Click next, finish. Okay. Next. So I need, what are the components required? You just say, I need BC107 transistor. Go here, find the device here, BC107. BC107 bipolar silicon transistor. Click OK. Place somewhere here. Okay, this is my BC107. And what you need, I need one voltmeter and one ammeter to the base. Virtual instruments, click on DC ammeter, place here. And you need one DC voltmeter. Click here. And you need another voltmeter and ammeter on the output side. You need another DC voltmeter. Place between collector and emitter. And one ammeter, DC ammeter, I'll place here. Okay. So here in the circuit, this side should come positive and this side should come negative. So you click here, Y mirror you do. So Y mirror means, sorry, X mirror. X mirror, this side becomes positive and this side becomes negative. And the base current is measured in, this you write as IB. And the base current is measured in microamps. And output current is collector current, and it is measured in milliamps. Okay. Now what you need? I need 1 kilo ohm resistor at the base. So go to the component mode, pick component resistor. Click generic register I'm taking, click OK and place here. Okay, the value of this should be 1 kilo ohm. Right click on this and change the property 1 kilo ohm. Now what I need one regulated variable power supply. So you go and V source you type. V source. Okay, click OK. I'll place here. And I want to make this as a variable DC power supply. I need a pot. Type pot. So here you will get pot HZ you select. It is highly granular interactive potentiometer. Click OK and place the potentiometer here. And on the output side also you need one potentiometer. I'll bring this side. Okay. And I need one DC V source also on the output side. Okay. Now your work is to join all the things now. So first join the microammeter to base, register to ammeter, and one end of potentiometer to DC voltage source, another end to potentiometer, and the wiper of the first potentiometer to register. And this should be connected to ammeter and voltmeter between base and ammeter, and collector should go to ammeter negative. You check here, collector is connected to ammeter negative, and this should be connected to wiper. Okay, and this should be connected to positive of DC source, and negative of DC source should be connected to another terminal of the wiper potentiometer. And I'll bring this down, and this should be connected between collector and emitter. Okay, next I need one ground. Choose ground and connect here. Okay, now everything is ready. So here I'll increase some voltage. Edit property, I'll keep this at 5 volts. Let input be 1 volt because I can get many values in terms of 0 0.1, 0 0.2, 0 0.3 like that. So now first you should, what is the output input characteristics says? So we should keep VC voltage at some fixed value, then vary the VBE. So using this pot, I'll fix the VC voltage. Make this 0, and using this, I'll make the voltage at plus 1 volt, VC 1 volt. See, you can check here. So if you want to see this clearly, you go to view and click on zoom in. You can clearly see the circuit. So VC is showing 1 volt because I adjusted the pot. So I got 1 volt. Now your work is to increase the VBE voltage and note down the IV current. Okay, so before that, I'll open the Excel, Microsoft Excel, and I write the values. Here I'll write VC is equal to 1 volt. I'm keeping this as constant. Here I'll write VB versus IB, VB in one column and IB in another column. Okay. So here I will take the readings. Okay. Initially, VB is 0 and IB is also 0. VB is 0, IB is 0. Now I'll increase one step. VB is 0.01, current is 0. 0.01, current is 0. 0.01 volts, current is 0. Next, VB is 0.02, current is 0. 0.03, current is 0. 0.04, current is 0. 0.1, current is 0. 0.1, current is 0. 0.2, current is 0. Keep on increase. 0.3, current is 0. 0.4, current is 0. 0.5, current is 0.01. So up to 0.4, current was 0. 0.1, 0.1, current is 0. 0.2, up to 0.4, current is 0. And 0.5, current I got 0.01. How much I got? Current is 0.01 microamps. 0.01 microamps. IB in microamps. Microamps. Okay. Next. I will make 0.55 for 0.05, 0.04, 0.55. Current is 0.04 microamps. 0.04 microamps. 0.58. I'm skipping 0.6, 0.7 all. 0.58, I got my more current. 0.58. 0.58, I got 0.11. 11 microamps current. Current is increasing now. 0.6. 0.6. 0.24 I got. 0.24 microamps for 0.6. Okay. Next. 0.65, 1.53, 1.53, 0.65 current. 0.7, 10.1, 10.1, 0.7. So I'll take only these many readings because as the base current increases, the voltage what I kept 1 volt, it starts dropping. So I'll not take further readings. So see here from which voltage it is reducing. Up to 0.6, I was having almost 1 volt. After 0.6, the current starts increases and the voltage starts dropping between the collector and the emitter. Now I got all these values. I'll stop the simulation. I'll select all these values. Okay. And click on insert, click on scatter, click on scatter with straight line. So I got VB versus IB. So this is my curve. So for VC equal to 1 volt. So go here, go to layout, axis titles, horizontal axis. Here you give IB current, and in vertical axis you give IB, IB in a horizontal, it is VB, not IB, VB versus IB, VBE, VB versus IB, keeping VCE constant. So you can give the title input characteristics. Input characteristics. Okay. So in this way, I get the curve. See, for almost 0.6, the current is 0. After 0.6, the current starts increases. So in this way, you can draw the characteristics curve in Excel sheet. So for the next setup, you bring this to 0 again. Make this to 0. Okay. Then so this you make 2 volts. We see earlier I made 1 volt. Now I'll make this as 2 volts. Okay. 2 volts. Again, you start repeating the same procedure. With zero for 0 volt, 0 current, again increase in one step. You take the set of readings.